Welcome to the introduction to Git and GitHub. This is Anne. She has a great idea. Maybe for a design, or code, or just a document, or all three. She puts the files for these in a folder called Thing, and then gives a copy to Kim, who in turn shares them with Tom. Then Anne improves the design a little bit and updates the document describing it. She gives the new version to Kim, but doesn't know that Tom has them. Meanwhile, Tom also improved the design, but in a different way. Now Pam learns about the thing and wants to make and sell it. Who should she ask? Who, if anyone, is entitled to compensation? At this point, who actually has the most recent version of Thing? Nobody knows. And that's where Git and revision control come in. Revision control is all about tracking the changes made to files and who makes those changes. Git is perhaps the most popular revision control tool available today. Let's look at this story again. This time, Anne puts the files in a folder along with a license file and creates a Git repository in the folder. She commits the current version of the files to the Git repository. Maybe she even tags the version of the files as being release 1.0 for future reference. When Kim wants the files, they agree to share the repository on a site like GitHub. When Anne makes her changes, she creates a branch of the repository so that she can track her changes without affecting other people. The branch allows her to back up her changes to the repository on GitHub while she is working on them. This means that when her drink spills on her computer a day later, she doesn't lose the files and can continue to work on them at a local library until she has her own working computer again. Meanwhile, Kim tells Tom about the repository. Tom creates a special kind of copy of the repository called a fork on GitHub for his own use. Tom makes his changes to a branch in his repository on GitHub. Anne manages to complete the changes she was making and merges them into the main branch of the repository she shares with Kim. Kim can see the changes have been made and can get the latest version for herself. Now Tom is ready with his changes. He pulls the changes from Anne's repository into his and sees Anne's changes. They have both modified the same file, so he incorporates his changes with the newer version of Anne's file. Then he submits something called a pull request to Anne's repository. Anne looks over the changes and likes them and merges them into her repository. Now when Pam wants to make and sell the thing, everyone knows where the authoritative version lives and everyone who has contributed to the creation of it. Let's look at how to create a GitHub account and then use it to create a repository that we can use to manage files. Creating a GitHub account is simple. First, navigate to github.com. In the upper right, click the Sign Up button and walk through the questions. Enter your email address and choose a password or use the auto-generated complex password. If you do the latter, be sure to save it for future use. Then pick a username and choose whether you want to receive emails from GitHub. Now you get to prove that you are a human and not a computer bot. First, by recognizing a picture, then by entering the confirmation code that was emailed to you. For now, just tell GitHub the account isn't part of a group. and pick the Continue for Free option. Once you are through the account generation process, you can either click Read the Guide or Start a Project. Today, I'm going to click Start a Project. You can come back to the guide later by simply visiting https://github.com/help. We start by giving the repository a name and a short description. For this demo, I'm going to create a repository called Simple. You can choose to make your repository either public or private. Being public means that anyone can see and download the contents of the project. Being private means that you have to explicitly share the project with them for them to have access. This can be changed later in the repository settings, so I'm going to pick private. I'm going to add a README file to the project and pick a license. Then click Create Repository. After a moment, GitHub will display the main page for the repository. Let's take a moment to talk about what a repository is. A repository contains all copies of all files that have ever been stored in them. The process of registering and storing a new file or changes to an existing file is called a commit to the repository. It is an action that a person performs. A repository keeps track of what version of a file was changed to create a new version of the file. For example, a repository that contains file 1 and file 2 knows that file 1 version A was changed to create file 1 version B. Likewise, the commit afterwards changes file 2 from version A to a new version. This ability to know what the previous versions of all files are allows us to create branches in the change history. By tradition, the default branch is called main. Here we create two separate branches for the purpose of making two separate kinds of changes. The one on the left adds file 3, while the one on the right further modifies file 2. There may be multiple changes to file 2 before all of the changes are complete and are ready for merging back into the main branch for general use by everyone. The process of merging is done when the author of the branch generates what is called a pull request. At this point, the changes get reviewed by the owners of the repository to make sure they represent the new best state of the project. If the changes are accepted, they are then merged into the main branch. When the branch on the left is ready, the user typically pulls the changes from the main branch into the branch before a pull request is generated. This allows the user to discover whether there have been any conflicts in the changes that need to be resolved. Then the pull request for the changes to the left branch is made. They are reviewed by the repository owner and accepted into the main branch. Let's see this in action on our GitHub repository. Right now, we are on the branch called main. We are going to make changes to the documentation, so we start by creating a documentation branch. Once in the documentation branch, I'm going to click on the README file and edit it right here in GitHub. For now, I'm just going to make the one line of text a little longer. When I have it finished, I click Preview and prepare the commit message. By convention, this message is typically a direction you would give someone to have them create the changes being committed. Here, the direction is to make the README longer. There is a box for more extended description of the change being made. Finally, we commit the change to the documentation branch. If we look at the main branch, the changes haven't been recorded here. Only the documentation branch of the repository has the new version of the README file. To generate the pull request, we click on the Pull Request menu item, then click the green New Pull Request button. We select the documentation branch as the branch we want to be pulled into the main branch. Here we can see and check the changes that were made to the files within this commit. In this case, it is just one file. Click the Create Pull Request to generate the request. We could edit the message for the request here, but I'll just keep the text from the last commit and click Create Pull Request to finalize the request. Since this is a pull request in a single repository, we immediately see the review of the pull request. In this case, it is all fine, so we click Confirm Merge. Now, if we look at the documentation branch and the main branch, we see they both have the same version of the README file. Let's add another file to the repository on the documentation branch. I'm going to click on Add File and select Upload Files to simply add files from my computer to the repository. I have a file of random text called lorem ipsum, which I will drag into the web browser. I'll write my commit message and click Commit Changes. Now we can see that the documentation branch has the new file. Just like before, we can see that the main branch doesn't yet have the file. Let's generate the pull request to add the new file to the main branch of the repository. Click on the Pull Requests menu item, click New Pull Request, select the documentation branch as the source to be pulled from, confirm this is the content we want pulled into the main branch, and click Create Pull Request. Review the text of the actual request and click Create Pull Request again. Now, in our role as reviewer, we review the request and merge it into the main branch. Now, both documentation and main branches have the new file. So far, we have been doing all of our interaction directly with GitHub in a web browser. Now let's see how we can use Git and GitHub together to manage files using our local computer. We're going to start by downloading and installing the software. First, we navigate to the website for Git, which is https://git-scm.com. Click on the blue-green monitor to download the latest version of Git for your computer. On the download page, click on the Click Here to Download link and click Save File to save the file to your local computer. If you go back to the home page for Git, you'll find a link for documentation. If you follow this link, you will find the book Pro Git. This is an excellent learning resource. I highly recommend it. Now back to your computer. Double-click the installer in your Downloads folder to install the software. If you like, you can accept the default values for all of the pages in the installer. Many people opt to change the name of the default branch that Git creates from the older master to the more modern term main. The installation process can take several minutes. For the purposes of this video, I've sped the process up considerably. Now we launch a program called Git GUI and select the Clone Existing Repository option from the startup screen. Git GUI is going to prompt you for the path of the repository to clone and the target directory where the local version of the repository should be kept. We get the source location from our GitHub repository. Open the web browser to the repository and click the green Code button. Then copy the URL for the repository. Back in Git GUI, paste the URL into the source location box. Then click the Browse button for the destination location. I'm going to select the My Documents folder and add the name Simple to the path so that Git GUI will create a subfolder for the repository. When Git GUI reaches out to retrieve the repository from GitHub, it needs to know how to tell GitHub we have permission to read the repository. The best way I have found to do this is to create and use a token for Git to use to authenticate to GitHub. Select Token in the dialog box, then open your web browser for GitHub. Click on your ID in the upper right and select Settings. Scroll down to the bottom left to Developer Settings. Then select Personal Access Tokens. Select Generate New Token and give the token a name. I'll use First Token as the name. I will leave the expiration date for the token at 30 days and check the repo box to give the token access to my GitHub repositories. Scroll to the bottom and click Generate Token. Once the token is generated, click to copy the token to the clipboard. Paste the token into the GitHub sign-in box and press Enter or click the Sign In button. Git will copy the entire repository from GitHub to your local computer. When this is complete, you will see the Git GUI window for your local repository. Right now there are no changes to the repository, so there is nothing in any of the panes of the window. If we click the Repository menu and select Visualize All Branches, it will open another program called Git K that will show you the history of the repository. Note that we can see each of the changes that have been made to the repository so far. We're going to add some files to the repository on the local machine. So we're going to create a branch in the local repository. Right-click on the line for the main branch and select Create New Branch. I'm going to name the branch Geometry, since I will be adding geometry files to the repository. Now right-click on the new branch's name and select Check out this branch. I'm going to open a file browser window to the folder where my local repository lives. I'm going to drag in some geometry files to the repository folder. You can pick some files that you have. Now if I bring the Git GUI window to the foreground, I can click on Rescan and it will find the new files and list them in the Unstaged Changes section. Click on the icon for the file you have added to stage the file. This effectively tells Git that you are intending for this file to be added as a part of the next commit to the repository. If Git thinks your file is a text file, it may warn you that it's going to change the way line endings are stored in the repository version. This typically won't change your local working copy. Don't worry about the dialog box. Simply click the Unlock Index button and proceed. Do each of the files in turn. Now it's time to write the commit message for the changes we are making to the repository. Once that is done, click the Commit button to add the files to the Git repository. Finally, click the Push button. Git GUI will ask which branch you want to push. By default, it is the currently checked out branch, which is what we want in this case. Click the Push button and Git GUI will update the repository on GitHub. If we open the web browser again and look at the repository on GitHub, we can navigate back to the repository by selecting our name, selecting your repositories, and choosing the name of the repository from the list. If we check the list of branches, we will see the new geometry branch. Once again, generate the pull request to merge the contents of the geometry branch into the main branch. Finally, perform the merge. I hope you've enjoyed this brief introduction to Git and GitHub. If you want to know more, there are plenty of online resources besides this video. If you go back to the home page for Git, you'll find a link for documentation. If you follow this link, you will find the book Pro Git. This is an excellent learning resource. I highly recommend it. If you visit docs.github.com, you will find a variety of learning materials there as well.